So on this video, I'm going to be talking you through the solutions to the Paper 2 AS Maths from the 23rd of May 2018. Now the paper itself was as I'm sure you know, was some statistics questions in section A and then mechanics questions section B. Now in this video, I'm only going to be looking at the mechanics questions. So I'll start off with the question itself, so you can pause the video at that point if you wish. I'll then move on for each question onto a hint, and then finally I'll move on to talking you through a work solution. So starting off on the first mechanics question, which is question 6. So I think a little sketch just helps you gather your thoughts each time. So simple little sketch. I'm starting 2 meters up in the air, and I've got an initial speed upwards of 9, and then I hit the ground again a bit later. So I would always choose to resolve in the direction of the initial movement, which is upwards. So I'm resolving upwards. So my initial speed is 9. My acceleration is minus 10, because obviously gravity is going downwards. And the displacement, where I finish up compared to my starting point, given that I'm resolving upwards, is minus 2. So U is 9, A is minus 10, S is minus 2. We need to work out T, so choose the appropriate Suvat equation, which includes U, A, S and T, and substitute in to find what T is. So the solution for question 6. So as I described in the hint, we're resolving upwards. Our initial speed is 9. Our acceleration is minus 10. And the displacement is minus 2. Is 2 below where we're starting from. Now using S equals UT plus half AT squared, substituting in and rearranging, I get this quadratic. So A is 5, B is minus 9, C is minus 2. Just popping that into the calculator, we get 2 possible values of time, being 2 and minus a fifth. Clearly you can't have a negative time, so T is 2 seconds. Question 7. So for part A, part AI, we know our initial speed is 0 as we're starting from rest. We're told the acceleration is 0.3, and so A is 0.3, and we're told it's traveling for 80 seconds, so T is 80. So just substitute into the appropriate Suvat equation to work out what V is. Now for part A2, state the time for which the train is decelerating. Well, our initial speed is 24. Our final speed is going to be 0, and we're decelerating, so our acceleration is negative at 0.5. So substitute into the appropriate Suvat equation to work out what T is. Now for part 3, the hint I'm just giving you is the general shape, okay? You're going to have to work out the various numbers for that. So time along the bottom, velocity up the side. So we're accelerating at a constant rate. Accelerating at a constant rate, then we've got constant acceleration, and then we've got a period where we're decelerating at a constant rate. Now for part B, the key bit here to take on board is the area under the graph of a velocity time graph is the distance travelled. So we're saying the area under here equals 4,800. So assuming you've got the numbers right here, the area of this triangle plus the area of this rectangle plus the area of this triangle equals 4,800. And my only hint for part C is make sure you answer the question, what improvement that could be made to the motion of the train. So we're talking about the motion of the train, not anything else. And the solution for question 7. So following on from the hints, for A part I, U is 0, A is 0.3, T is 80. Using V equals U plus AT, we get a velocity of 24. Now for part 2, U is 24, V is 0, A, the acceleration is minus 0.5. Again, using V equals U plus AT, we get time being 48 seconds. So here is my velocity time graph. So for the first 80 seconds I travel, I end up with a final velocity of 24. I then have a period of time over which I'm calling x, where I go at a constant speed. So by then I've gone a distance, the time will have been 80 plus x, okay? And then finally I've got a period of 48 seconds. So from 80 plus x, another 40 will take me to 128 plus x, by which time my velocity becomes 0. So those are the key numbers for part 3. And then for part B, the area under the graph is the distance travelled, which is 4,800 meters. So just breaking it down into the 3 bits, I've got the area of the triangle in orange, so half times base times height, half times 80 times 24, that's my 960. Then the area of this rectangle, which is 24 times x. Then thirdly, the area of the green triangle, half times 48 times 24. Those 3 added together give me 4,800. X is now my only unknown, so I can work out that x is 136. Now the question actually asks for the time taken for the train to travel from A to B, so it's going to be the 128 plus the x, so 128 plus the 136, which is 264 seconds. Question 8. So the hints for this, find the times, so it's going to be plural, when P is instantaneously at rest. Now, a really key point for mechanics, you're instantaneously at rest when your velocity equals 0. So multiply out the displacement formula, so do half t squared times the minus 2t and times the plus 1 to give us a revised displacement formula. You can then go and differentiate that. The differential of displacement, differential of x, is the velocity. So differentiate this, set it equal to 0, and work out your various times. It's going to be a number of times when P is instantaneously at rest. Now for part B, you're going to take the times from part A. So in a way, I'm giving you the answer here for part A. All right, the various times we got were after a half a second, 1 second, and 2 seconds for part A. Now for part B, the total distance travelled is what it says. So it's the amount of time you're travelling to the right, then back to the left, then back to the right again. So it's not the overall displacement. It's not where you end up compared to where you started. It's the total distance travelled. So you've got to work out when time is 0 where you are, what is x when time is 0, the displacement when time is 0, then work out the displacement when time is a half and take one away from the other to work out how far you've gone between 0 and half a second. Then go and work out where you are, your displacement when time is 1, okay? And then take that away from where you were when time was a half to work out another little bit of distance travelled. Then finally, work out displacement when time is 2, and that's where you are after 2 seconds. Take that away from where you were after 1 second, and that gives you a third piece of distance. Add those 3 distances together, and that will give you the total distance travelled. So part B is really testing your understanding of the difference between displacement, which is where you are at any particular point in time compared to where you started, and distance travelled. Okay, so your displacement will be 0 when you're back where you started, but obviously you've been travelling a number of times to the left and to the right, etc., to get there. So your distance travel will be different from your displacement. Now for part C, the key bit for part C is that you've got to pick up the fact that you can the bracket for the displacement formula, you can complete the square on that, and that is t minus 1 all squared. So t squared minus 2t plus 1 is actually t minus 1 all squared. So because you're squaring these things, you can really conclude that each component can never be negative. T squared, the smallest that can be is 0. Okay, so t squared is greater than or is equal to 0, whereas t minus 1 squared by definition is greater than 0. Okay, so t minus 1 all squared is greater than or equal to 0. So overall, x must be greater than 0, hence why you never move along the negative axis. So the solution to question 8. So we're instantaneously at rest when v equals 0. So multiplying out the displacement equation, I get this one here, half t to the power of 4, etc. Differentiating that, I get dx dt, obviously, which is velocity. So remember how to differentiate, multiply by the current power, reduce the power by 1 for each of the 3 terms, and then set that equal to 0. So I've then gone and factorised it and taken out the t, and then I've factorised the quadratic, and I can see that I get my solutions when t is 0, a half, and 1 second. Okay, so each of these 3 components, this is obviously 0 when t is 0, t is a half, t is 1. So I'm at rest at 0, a half, and 1 second, and also yeah, so that's when I'm at rest. So those are my 3 answers for part 1, for part A. Now for part B, total distance travelled. So I'm going to work out where I am, my displacement, when I start and when I finish at 0 and 2, and also when I'm changing direction, when I'm at rest, so when t is a half and t is 1. So my displacement of those 4 occasions are these values for x. So what is my distance travelled? Well, how far do I go from when t is 0 to t is a half? Well, my displacement goes from 0 to 1 over 32. So I've travelled a distance of 1 over 32 meters. Okay, so I go from t being 0 to t being a half. Now, when I get to t is 1, I'm back to a displacement of 0. So I've gone back to where I've started. So that's another distance of 1 over 32 as I've gone back to where I started. Now, when t is 2, my displacement is 2. So I've effectively gone 2 to the right, say. So I go 1 over 32 to the right, then back 1 over 32, and then forward 2. So that's a total distance of 1 over 32, add 1 over 32, add 2, which is 2 1/16. Now for part C, as I mentioned in the hint, you've got to pick up from the displacement formula that t squared minus 2t plus 1, you can complete the square there and get t minus 1 all squared. And then really you've just then got to conclude that t squared by definition is greater than equal to 0. T minus 1 all squared is always going to be greater than 0. So if one component is greater than or equal to 0 and the other is always greater than 0, then by definition displacement is going to be greater than or equal to 0. So we'll never move along the negative axis. Question 9. So for the hint, I'm going to just draw a sketch. Okay, now so the key bit, okay, whenever you have one of these pulley questions, obviously the 2 weights are going downwards. Okay, so weight is the mass times the acceleration, so that the weight here is 2 mg and the weight here is kmg. Okay, and then always remember that the tensions are both going upwards towards the pulley. So so that's key, and obviously we're accelerating downwards on the left and we're accelerating upwards on the right at the same rate, and that is because they tell us that k is less than 2. So p is heavier, so it's going to be going down on the left and up on the right. Now for part A, we're being asked to work out the tension in the string in terms of M and G. So your final answers will have M and G in it. Now we can either resolve from the point of view of P or Q, but for part A you're going to have to do it from the point of view of P, because we can't do it from Q because we would have 2 unknowns being both K and T. However, when we resolve from the point of view of P, our only unknown is going to be T. I mean, we don't know M, but our final answer is going to be in terms of M anyway. Okay, so we're resolving from the point of view of P, resolve in the direction of motion, which is downwards, and then your key point is F equals ma. That's your starting point. So what is your net force going downwards? So is 2mg greater than T, or is T greater than 2mg? So net off those 2 forces on the left-hand side, and then that's equal to mass times the acceleration. So substitute in there, and then rearranged to make T the subject, and it will be, your answer will be in terms of M and G. Now for part B, why is the acceleration of Q also the same? So just think about it. How come that the acceleration downwards is the same as the acceleration upwards? What part of the question makes it clear that from the facts that were given, how do we know that that acceleration is going to be the same? Now for part C, we're now going to resolve from the point of view of Q, and again resolve in the direction of motion which is upwards. F equals ma is your starting point, so your two forces that you're netting off on the left of this equation will be T and kmg. Which one's greater? So make sure you get it the right way round. Okay, is it T minus kmg or kmg minus T? And then you know what the tension is from part A of your answer, so so you've got all the unknowns to allow you to work out what T is. To work out what K is. So the solutions for question 9. So for part A, we're going to resolve from the point of view of P, resolve in the direction of motion, which is downwards, and just write down F equals ma to help you gather your thoughts. Now, the forces involved on P are 2mg going downwards and the tension going upwards. Because the motion is downwards, the downwards force must be greater. So your net force is going to be 2mg minus T. So be very clear in your mind why it's that way around. 2mg must be greater than the tension, otherwise we would be going upwards. So that's our net force on the left. Our mass is 2m and our acceleration is 5g over 7. So rearrange that to make T the subject and simplify it. We get T being 4/7 mg. Now for part B, the reason that Q is accelerating upwards at the same rate as P is accelerating downwards is because the string is being modelled as inextensible. So it's not stretchy. So by definition, one going down must be going down at the same acceleration as the other one is going upwards. Now for part C, we're going to resolve from the point of view resolve for Q. Again, resolve in the direction of motion, which is upwards. And again, start off by writing down F equals ma. Okay, now it's going upwards, so the tension must be greater than the weight. So on this occasion, it's going to be T minus kmg. Okay, not the other way around. So that's our net force, and that equals the mass, which is km, multiplied by the acceleration, which is 5g over 7 again. Now what I've then gone and done, I've substituted in the tension, which I know from part A of the answer. So 4/7 mg, and then I've just multiplied by 7, divided through by mg, rearranged, and I can work out that K is a third. Now for part D, identify one limitation of the model that will affect the accuracy of your answer to part C. Well, I've just copied and pasted this out of the answer scheme. So the model does not take account of the mass of the string. You could have said that, or the pulley may not be smooth, or the pulley has mass.